Our next lesson is called negative exponents. So we'll start with a discovery activity. You're going to complete the following charts using a calculator. Remember that when you enter a power, you enter the base, hit that insert key, and then the exponent. So it might look something like 2, then that insert key, and then your exponent, and then enter in order to get the values. Now today, it's not going to be as easy as it was in the previous lesson to write these numbers as fractions. So this piece of information is really important for the decimal to fraction portion. Now on your calculator, if you're not using the TI-30X2S and you're using the one we use in class, it might just give you the fraction automatically and you won't have to worry about this. But if not, remember that there is a second key, and as long as you get to F arrow D, it changes things from fractions to decimals for you. So you may have to hit that key or the simplify key in order to get the fraction that you need. So you can see that I took the tables from our previous lesson and I already inputted that information for you. Your job is to fill in the rest of the table looking at negative exponents today. We're trying to figure out what the rule is when we have a negative number in the exponent position. So you're going to pause the video and fill in these two tables on your own. Then you're going to answer the question that you see underneath. What do you notice about negative exponents? So at this time, pause, complete the discovery activity, then resume the video to go over your answers. All right, now that you had a chance to try, in the table on the left where you were doing powers of 2, after 2 to the 0, which is 1, you should have had 2 to the negative 1, which is 0.5 or 1/2, 2 to the negative 2, which is 0.25 or 1/4, and 2 to the negative 3, which is 0.125 and 1/8. For the table that had a base of negative 3 on the right, you should have had negative 3 to the negative first as negative 0.3 repeating or negative 1/3. You should have had negative 3 to the negative 2 as 0.1 repeating or 1/9. And you should have had negative 3 to the negative third as negative 0.037 repeating, which is negative 1/27. So I was hoping that you would see that when we have negative exponents, we're getting decimals and fractions. And the big idea is actually that the fraction values are reciprocals of each other. So I picked out an example of the table to show you. If I look at 2 to the third in the table, it's equal to 8 or 8 over 1. If I make that 3 a negative 3 in the exponent instead, all it does is take my answer and flip it. 2 to the negative 3 is 1/8. And if you look at the rest of the table, this holds true the whole time. So if I look at this, do you see that 2 to the positive 2 is 4 over 1? But 2 to the negative 2 is 1 over 4. 2 to the positive 1 is 2 over 1. 2 to the negative 1 is 1 over 2. The answer is just flipped. So take a second to write down what you need from this portion, and now we're going to move on and discuss why this works and look at some examples. So let's investigate further together. Simplify the following expression using our division exponent rule. So that's what we're going to do first. We're going to use an old rule. For division, we know that we should be subtracting our exponents and keeping our base. So we are going to keep the base of 8 here and subtract our exponents. 5 minus 3 is 2, 8 squared. And for this purpose, I'm just going to leave these in exponential notation. So this property makes a lot of sense, this property of the division exponent rule, as long as the numerator is greater than the exponent in the denominator. So here, the exponent on top was 5, the exponent on the bottom was 3, and 5 is greater than 3. So when we do 5 take away 3, we're getting a nice number that we're used to, positive 2 in the exponent, and we could move from there and evaluate. But my question is this one. What if the exponent in the numerator is smaller than the exponent in the denominator? So we're going to look at that in our next example. Again, we're going to use a rule that we already know. We're going to simplify the following expression using our division exponent rule, which means we subtract. So if we continue to use our rule, we're going to keep our base of 8, and we're going to subtract our exponents, but we're doing 3, the top, minus the bottom. So for the very first time, the number on top is smaller than the one on the bottom. When I subtract these, 3 take away 5 is actually -2. So we're going to run into negative exponents anytime the exponent on the bottom is larger than the one that's on top. So why do we even get a negative exponent? Let's look at it in a different way. We're going to go back to how we investigated our other rules. We're going to expand and simplify the fraction by cross-canceling those common factors. So 8 to the third, the base is 8, and we're going to multiply it by itself 3 times. On the bottom, the base is also 8, but we're going to multiply it by itself 5 times. Now, what we learned before is that any number divided by itself cancels out because that number divided by itself is a 1. So we can cancel these, and these. They leave 1s behind. So on top, 1 times 1 times 1 is 1. And on the bottom, 1 times 1 times 1 is 1, times 8 times 8. So we really just have 2 8s left on the bottom, which we can rewrite as 1 over 8 squared. So now you see that same problem we started with, 8 to the third over 8 to the fifth in both of these situations. You can see that these answers then must be the same. 8 to the -2 is the same as 1 over 8 to the +2. So when you get rid of that negative in the exponent, it moves everything to the bottom of the fraction, and that exponent becomes positive. So let's look at it in this diagram that we see here. We are taking a base to a negative exponent and flipping it so that it becomes 1 over that same base to a positive exponent. And I'll walk you through these steps as we try some of these examples. We're going to make sure the first number is a fraction if necessary, so that we can then take the reciprocal of it and change the sign on that exponent from negative to positive. Another way you can think of it is this phrase that we listed below. Negative exponents are sad. It means the power's on the wrong side of the fraction bar. That means it's on the top when it should be on the bottom. So we're going to move that power to the other side of the fraction bar, which is the bottom, and change it to a positive exponent. And then we'll be happy again. So let's look at some examples together. In number 1, 6 is the base, and as a fraction, that's really 6 over 1. So that negative exponent means I'm going to take it and flip it, and the exponent that was negative would become positive. So that's 1 over 6 to the first, or just 1 over 6. In number 2, want to show you that you can do that with a variable. So x, I'm going to write as a fraction because it's not currently 1. And that negative in the exponent tells me I'm going to take it and flip it. When I flip it, that exponent that was negative becomes positive. So it was unhappy in the other side of the fraction bar. Now we move it to the right side and it's happy and positive. In number 3, and moving on, we're going to look at how this comes about when we have multiple rules used. So in number 3, this is a fraction. So this is a division problem. So we're going to keep our base and subtract our exponents. But you see my exponent on top is smaller than my one on the bottom. So when we do 2 minus 5, we're going to get a -3. So we're going to make sure this is written as a fraction. We're going to take it and flip it. I'm still keeping my base the same. -4 is my base. It's still my base as I flip it. The only thing that changes is the -3 becomes a +3. If we were to do this on our calculator, we'd get 1 over 64. So be very careful you don't change the base in any way. You only change the sign on the exponent. In number 4, We are doing division again. However, on top, it looks like we don't even have an exponent, which we now know is not true. There's really a little 1 there. And we're going to put a star next to number 4 because this is a tricky one. And this is another one where we're going to write a note and say, write it out. So I'm going to keep my base of 5 for division. The top exponent is a 1. I'm subtracting because that's the rule for division. The exponent on the bottom is a -3. So if I use my division rule the way I'm supposed to, I'll see that these are now plus signs, and this is just 5 to the 4th. And those negative exponents actually ended up not being an issue in this problem. 5 to the 4th on the calculator would give you 625. Now let's look at number 5. 3 to the 4th times 3 to the -6. This is a multiplication problem. So we're going to keep our base of 3, and we're going to add our exponents. 4 plus a -6 makes a -2. So if it's not already written as a fraction, I'm going to write it as a fraction by putting it over 1, and I'm going to flip it. My base stays the same, but my exponent changes from negative to positive. So 1 over 3 squared is the same as 1/9. In 6, we have power to a power on the top and the bottom, also with division. So we want to take care of our power to a power first. 2 times 3 would give me 2 to the 6th. We're multiplying for power to a power. 5 times 2 would give me 2 to the 10th. So now we have a division problem where you can see the numerator exponent is smaller than the denominator exponent. So we're going to keep our base, 2. And then we're going to subtract our exponents. 6 take away 10 is -4. So I'll write that as a fraction and flip it. Once I flip it, that exponent that was -4 becomes +4. And this would be the same as 1 over 16. So now what I would like you to do is a bunch of practice. We're going to rewrite each expression in simplest form. So you're going to use your exponent rule first, write it in exponential notation, and then any numerical expressions we're also going to evaluate because once again, we want to practice both ways. We never know how the question is going to be presented to us. So this is going to have a mixture of negative exponents and your other exponent rules that you've learned prior to this. So to recap quickly, when you're multiplying, you add your exponents and keep the base. That means when you're dividing, you keep the base and subtract your exponents. Power to a power, you multiply. Anything to the 0 power is 1. And now you know what to do with negative exponents. Move it to the opposite side of the fraction and change your negative exponent to a positive exponent. So at this time, I'd like you to pause the video and try the practice questions 1 through 8, and then resume the video to go over the answers. In number 1, -11 written over 1 means I'm going to take it and flip it and change my exponent from a -2 to a +2. Make sure when you type this in the calculator, you include the parentheses around the -11 since it's a negative base, and you get 1 over 121. In number 2, y to the -12 becomes 1 over y to the +12. Reciprocal, you flipped it. In number 3, you must do power to a power first. So you're going to multiply -3 and 2 to get -6. Then you can put 10 over 1 and flip it. It becomes 1 over 10 to the +6. That exponent changes from negative to positive, which is 1,000,000. In number 4, you are multiplying. So you're going to add your exponents, 9 to the -4, which flips to become 1 over 9 to the +4, or 1 over 6,561. In number 5, the top exponent is smaller than the bottom. So when you do 7 minus 10, you're getting 6 to the -3, which becomes 1 over 6 to the +3. The exponent changes to positive when you flip it, which is 1 over 216. In 6, you have a -1, and you're subtracting, because that's the rule for division, a 3. So -1 minus 3 is -4. When you flip that, that becomes 1 over 4 to the +4, which is 1 over 256. So be careful of that one, because that is not the same thing as you do in 7. In 7, you've got a +2 on top, You're subtracting because that's the rule. You can see that in pink. A negative 1 as the exponent on the bottom. So those double negatives actually make it 12 to the third, which is 1,728. And then in number 8, you have power to a power. 4 times 3 is 12. When you multiply those, you add your exponents to get 8 to the negative 3. Then it flips to become 1 over 8 to the positive 3, which is 1 over 512. So now as a closure challenge, it says the expression 2 to the third times 2 to the negative 1, all raised to the negative 2, can be written as 1/16. Show using your exponent rules how this can be done and explain your steps. So I'd like you to pause the video and try this closure challenge, then resume the video when you're ready to go over the answers. So now let's go over the closure challenge. Looking at that expression, I'm going to complete what's in parentheses first. Multiplication is inside the parentheses, so 2 to the third times 2 to the negative 1. I would want to keep my base of 2 and add my exponents. 3 plus a negative 1 would give me 2 squared, as you can see here. That still has to be raised to the negative 2 on the outside. So the next thing we will do is do power to a power as our exponent rule. We're going to multiply 2 and the negative 2 because that's the power to a power rule. So I would get 2 to the negative 4th because 2 times negative 2 is negative 4. We now know because of negative exponents that we are going to write the base as a fraction. So you see I put the 2 over 1. The negative and negative 4 is telling me to take that fraction and flip it. Once I flip it, the exponent that was negative becomes positive. So that becomes 1 over 2 to the positive 4th. Then when I evaluate that on my calculator, 1 is in the numerator and 2 to the 4th is equal to 16, which becomes the denominator. So I just successfully showed the expression 2 to the third times 2 to the negative 1 raised to the negative 2 power to be written as 1 over 16. I showed it using my exponent rules, and I also, next to those steps, explained my steps. So add the exponent, then multiply the exponents, then take the reciprocal and make that exponent positive. And that concludes our lesson on negative exponents.